So the objective of this class is for you to be able to understand coordinate systems, plot a point on a map, determine an azimuth between 2 points, and follow your compass in the right direction. So Laura, it was fun. For the most part, we were able to stay on top of the snow. It was kind of hard, crusty. But so there are other navigation techniques, other objectives, more advanced stuff. But really, what I want you to be able to do at the end of this class, considering for the most part we're going to be backpacking on trails, is when you get off the trail, when you cross the snowfield, when you get to an intersection that doesn't look familiar, I want you to be able to stop, to plot your location on the map. I want you to be able to determine the azimuth back to the trail, or determine the azimuth back to your camp. I want you to follow your compass in the right direction. Most of these, like lost hikers, most of the bodies that are found, most people are within a mile of the trail when they get lost and when they need search and rescue. So I want you to be able to just stop, sit down, get your grid coordinate, determine where you're at on your map, and follow your compass back to the trail. That's the end state of this class. Start off with a couple of definitions. I say azimuth because that's what the Army says. Boy Scouts say bearing. They mean the same thing. You're going to hear me say azimuth because I just have not trained myself to say bearing enough, and I probably never will. But so they're the same thing. Neither one's better than the other, but it's a horizontal angle measured clockwise from north. It's just like a circle from 0 to 360. Your azimuth is the direction that you are traveling. So in this example, the direction line right here is at 64 degrees. So that is your azimuth. You are traveling at 64 degrees for your azimuth. Your back azimuth is the opposite of your azimuth. So it is comparable to turning completely around. For example, if you were going 180 degrees, your back azimuth would be 0 or 360. Because it's a circle, there's no such thing as a negative azimuth. So you subtract 180 degrees if your azimuth is 180 degrees or more. You add 180 degrees if it's 180 degrees or less. I got 2 examples in there. So if you were traveling on a 115 degree azimuth, your back azimuth would be 295 because we added 180. If you were traveling on a 337 degree azimuth, your back azimuth would be 157. An example when you use a back azimuth is, say you were in grizzly country and you wanted to set your food bag up 50 to 100 meters away from camp. You would want to set an azimuth to go out to your food bag, and then you could calculate the back azimuth to come straight back to camp. You're going to hear me talk a lot about grid to magnetic or magnetic to grid. Your magnetic azimuth is when you use your compass to get the direction. So if you are using your compass to determine the azimuth, that's a magnetic azimuth. A grid azimuth is when you are using your map to determine the direction. So if you are on your map and you're using your map tool to determine the direction, that is a grid azimuth. And when you convert to grid, between magnetic and grid, using the declination angle. This is because, as we covered last class, there are multiple different norths. There's true north, which is the actual North Pole. There's magnetic north, which is where your compass points. There's grid north, because your grid lines will not be exactly true north, because they are attempting to depict a curved surface, the Earth, on a flat piece of paper. So those are going to get off a little bit. Declination is the difference between any 2 norths. For our purposes, we are primarily concerned about the declination angle between magnetic in grid north. So in this diagram here, I would add 14 and 10 to get a grid to magnetic declination angle of 24. And why do we need to know this? This is so we can navigate using a map, the ground, and a compass. Declination changes based on where you're at. As we covered last class, every map should have a declination diagram in the lower right corner. In Washington, it's going to be in the between 15 and 20. There, mouse, where'd you go? There's my, okay. Maybe. Oh, okay. Mouse is having a hard time there. So in Washington, it's going to be between 15 and 20. And as you go across the country, it changes. In the East Coast, it's going to change to a west declination. And so your declination diagram is going to have magnetic on the left side instead of the right side. Why is this important? This is how we're going to go to convert from our compass to our map and vice versa. And you use the acronym LARS, left add, right subtract, to determine that conversion. Some maps, especially military maps, will have it written out underneath the declination diagram. It's awesome. It's because the military likes to idiot-proof stuff, but they try very hard to. It's pretty much, it's impossible, but they try very hard to do it. And then, but a lot of civilian maps, USGS maps, won't have that. They'll just have the diagram itself. So you have to remember left add, right subtract. So the way that works is I'm going to say example 1, east declination. So say we're in Washington. We have 20-degree declination. If I want to convert from my map to my compass, I'm going to be going from grid to magnetic. So in this case, I'm going from grid to magnetic. That is a rightward movement on the declination diagram. I'm moving right on the declination diagram, so I'm going to subtract 20 degrees from my grid azimuth to convert it to magnetic. If, say for example, I used my compass and I shot a azimuth to, say, a mountain peak or something like that, and I wanted to convert that azimuth and put it on my map, I would be moving from magnetic to grid. That's a leftward movement, so I would add. So whatever number I got from my compass, by shooting that azimuth, I would add 20 degrees to it, and then I would draw that line on a map. And that line should intersect with the peak. What are your questions so far? Let me pull up the chat window. Yep. Dave, there are definitely compasses that adjust to where the GM, you can set the GM angle. I did that one time and I forgot to readjust it when I went somewhere else. And I got really confused when I kept being off all the time. It took me like the third time I used it, I was like, oh, whoops. I have the declination angle set for Alaska. Whoops. Just because the way I learned to navigate, I don't preset my GM angle now. I just put it on 0. That way I just remember it every time. Amy and Mittal, no, it is not safe to assume. The declination angle changes within the state and changes over time. So you'll want, if you have an older map for the area, you'll want to check the internet for the declination angle in that area. And Laura, we will have some examples earlier today. And if I'm not sure if everybody checked their emails before class, If you did get a chance, there's a handout in there so you can follow along during the practical examples. Okay.